Viewers, you're welcome to our MMC platform. Thank you for subscribing, following, and sharing. God bless you so much. So, today we are looking at item 2 of A-level sub-math, element of construct 2. This is a compulsory item. You know very well in section A there are 2 items that are compulsory, and now we are going to read this scenario, and it goes: a certain community in Uganda relies on nearby forests for firewood. Over the years, there has been an increase in the demand of firewood, which has caused a decrease in the number of trees in the forest. Environmentalists have modeled the number of trees T in the forest over time, as Tx is equal to 20,000 minus 1,500 x squared, where x is the time in years for the forest to get depleted. The community leadership is concerned that if this decrease continues at the same rate, the forest will get depleted, and therefore plans to have a sensitization meeting with the community members. During the meeting, the community leadership needs to make a detailed analysis of the model, including representing it graphically with a clear interpretation of the turning point and intercepts, so that the community members understand how big the forest initially was and when it will be depleted. Recently, another forest in the neighboring community caught fire, and by the time the fighters started putting out the fire, 100 hectares had burnt. It took 5 hours for the firefighters to stop the fire completely. The firefighters observed that the rate at which the fire spread was proportional to the area of the forest burnt, and the proportionality constant was 0.1 hectares per hour. However, the firefighters need to estimate the area of the forest remained after their intervention. Task: make the detailed analysis needed by the community leadership during the meeting. B. Address the need for the firefighters. We are looking at the solution for part A, and let's summarize that again. Said a certain community in Uganda relies on a nearby forest for firewood. Over the years, there has been an increase in the demand of firewood, which has caused a decrease in the number of trees in the forest. Environmentalists have modeled the number of trees T in the forest over time as, so this is the function for the number of trees, as T is equal to 200,000 minus 1,500 x squared, where x is the time in years. So our x, this one is the time in years, whereas our t is the number of trees, So now they are saying t is equal to t as a function of x is equal to 200,000 minus 1,500 x squared, where x is the time in years for the forest to get depleted. The community leadership is concerned that if this decrease continues in the same rate, the forest will get depleted, and therefore plans to have a sensitization meeting with the community members. During the meeting, the community leadership needs to make a detailed analysis of the model, including representing it graphically in this is graphically with a clear interpretation of the turning point. So we need the turning points. Turning points and intercepts. We shall also need the intercepts. Okay, intercepts, so that the community members understand how big the forest initially was and when it will be depleted. Okay, so now that is the first part of our scenario, and the task said make a detailed analysis needed by the community leadership during the meeting. Our dear viewers, this is a very good idea of the community helping to save the environment. We know very well once the forest is depleted, the environment or the climate changes are affected. That is why we have a lot of unreliable climates and the weather conditions. So now, according to this, we need to note the following. We shall need a graph, but before the graph, we need to know the turning points, and also we need to know the intercepts. So now, as this Tx is our function, let us start with the turning points. Now, turning points are those points on a graph that have a horizontal or gradient. In others, that have a zero gradient. So now, what we shall do, we shall formulate a gradient function. A gradient function. And for those of you who know that, how do we get the gradient function? By differentiating the given function. So we shall differentiate our function by saying dt dx will give us, now when you differentiate this one comes to a 0. Then when you differentiate this when you're differentiating, multiply the power by the coefficient. So 2 times 1,500 negative, that is negative 3,000 x, then reduce the power by 1. So this is what we call our gradient function. So after getting the gradient function, we shall say at the turning point, the gradient is a 0. So we shall substitute where dt dx is with a 0 and say 0 is equal to negative 3,000 x. So from there, how do we get to the value of x? Divide both sides by negative 3,000. So we shall come up with, therefore, our x is equal to 0. So, having found the value of our x, we are now required to get the point or the coordinate of that point by getting the value of tx. Our tx is like y on a coordinate axis. So what we shall do, we shall substitute where there is x, put a 0 and say, therefore, t of 0, when you substitute it in that function, this one square 0, this one vanishes, so that we have 200,000. So from there, since we have got the x and now like the y values, we conclude here and say the coordinates, therefore, will be, remember we start with our x value, then followed by our tx. Our tx is like y. So we shall say our coordinate is therefore 0 and 200,000. Okay, so that is one of the turning point coordinates. Very good. So now Having realized that, we also now need to know the nature of the turning point. Nature of the turning points. Now, some turning points are either maximum, others are minimum, others are points of inflection. So now, here, how do we know the turning point? We shall differentiate it the second time, so that we get the second derivative. If the outcome is a negative, then that will be maximum. If the outcome is a positive, then that will be a minimum. So, let us differentiate again the second time our function. So this squared t dx squared will give us, remember this is power 1 times this, that becomes that, then reduce the power by 1, so that we have a 0, is x power 0, so we shall have negative 3,000. Okay, so now, since our second derivative is a negative, therefore, this function has a maximum. So you can say since our second derivative is a negative, so our curve has a maximum. Okay, so it will be something like that, maximum. So now, after getting that reality, we can now proceed and get the intercepts. So now we want to get the intercepts. Intercepts are the points where the curve cuts the axis. So now, in the x-axis, y is 0. So we say, when y, our y is actually this tx. When tx is 0, okay, this is now in the x-axis. So when t of x is 0, what is x therefore? It is just a matter of substituting there. We say 0 is equal to 200,000 minus 1,500 x squared. So at this time, we can make this the subject. When this crosses the other side, we shall have our x squared as equal to 200,000, which can be negative all over, because we divide both sides by 1,500, which is also a negative. So this gives us our x. At this point, we can even get the square. This one becomes a positive, get the square root on both sides. We shall come up with 11.5. Actually, there will be two values, positive and negative. Because this is x squared, we shall have two values. So now, we shall have, so we can say, either, we can now find out, either x is at positive 11.5 or negative 11.5. So now, the coordinates will be, we have 11.5 and 0. Remember, this is like a y, t of x. So Then we shall also have negative 11.5 and 0. So, basing on all these coordinates and all this knowledge and all these coordinates, we can now sketch graphically. So now we can say here, graphically, we shall have that we can take, this is our y-axis or t of x, this is our x-axis or x, then this is our negative 11.5, this is our positive 11.5. So in a sketch, we have a maximum. Our turning point, remember, we got it at 0, 200,000. So this is 200,000. So this is point 0. So the coordinate 0, 200,000 is that. Then the point 11.5 and 0 is that. The point negative 11.50 is that. So now we can sketch, draw a sketch. Say we have got a maximum okay. So this is our graphical representation. So according to our scenario, we shall conclude and say, therefore, initially the forest had, this is now the maximum point. Initially the forest had, therefore, initially the forest had 200,000 trees. That is the initial point at the maximum. Then, if no intervention, the forest will take 11.5 years for complete destruction. For complete the destruction. I think you can see that by the time the forest comes to 0, the number of trees shall be, the number of years, remember this, our x here is the time in years. This is the time in years. So by the time it reaches 11.5 years, the number of trees will come to 0, or completely. This y-axis or tx-axis shows us the number of trees coming to 0. Thank you so much for following. God bless you. Turn on the bell, subscribe, and please share. Send in any scenario disturbing. Shalom.